Good morning, Kayla. I'm sorry you're not on. However, I'm going to um, present this week's material for you to get started on the class. We've missed one class, so we have a lot to cover in basically one lecture. The structure of the class will be as you've learned to expect. We'll have a discussion each week. We'll have two discussions each week. This is a complex class, so the reason there are two discussions every week is simply because the material is very important. These are basic concepts that you must understand and understand fully in terms of doing your job as a medical assistant. You will not be prescribing medications, but you will be discussing medications with the patients in the practice and giving people some instructions. Remember, as a medical assistant, you cannot counsel and you cannot prescribe, but you can interpret instructions and help people understand how to take their medications. Understanding medications means we have to understand the units of measure that are used in those, all sorts of units of measure, not just the amount of drug, but being able to calculate doses for patients. For instance, we usually use the metric system, and we'll go through units of measure in a while, but we usually use the metric system of measurement for calculating drugs. So we calculate drugs in grams sometimes, but not very often. Most drugs are much smaller in dose, milligrams and micrograms. Patients cannot be assumed to understand such terms. And so what we do is we give measurements in ways that that the patients can understand. And so we will we'll be doing that as well. For instance, when a patient is told to take a liquid drug, we give them a volume in a standard measurement of teaspoons or tablespoons because people in this country, at least, are more familiar with that unit of measure than milliliters. Outside this country, that's different. But here, what we have to deal with what we have. There will be an in-class exercise each week. This will usually involve a series of questions that you'll be answering on paper and submitting those answers to the submission box. If you're not in class, well, doing that will be very difficult. The week, each week there will be an assignment. These assignments are going to be worksheet based. So if you look at the assignment, there's some background material which you should always read. And it's this week's assignment is about basic mathematics and symbols that we use. And the prompt here tells you to download and complete a worksheet. You do not need to submit it, but what you do need to do is do a quiz. There is a quiz associated with this assignment. You've seen this before. So what you will do is the work, doing the calculations and so forth, and then transfer the answers into the quiz. The purpose of doing it this way is because the calculations take time, and it's a lot easier and quicker if you do those on your own and then simply enter the answers. So you're not actually doing less work this way. You're just doing the work in a slightly different order. So that will be graded, and I will see that grade. There will also be an assessment each week. The assessment will cover calculations, conversions, and what we call consequences. In this case, the consequences of mistakes in prescribing drugs. These can be devastating. So what you need to understand is those consequences and be able um, to see where and how these errors get made. Um, Doing math, as you know, because you've been actually in this class before, doing math is something that you just have to practice. Math is a skill. All of us have that skill. Much of it is inherent, but by being exposed in this society, we're doing math all the time. So um, what you do is the only way to learn this is to do a lot of practice. And so you'll be seeing a lot of that in this class. So the assessment will consist of a number of questions that are taken out of question banks. So you will be able to do that assessment carefully as well. I've extended the time for that quite a bit so that you can actually carefully go through the assessment and maximize your score. So this will be the structure, except the little short introduce yourself discussion. I put in a discussion about a mistake I made one time that was quite amusing, especially in retrospect. But I'd like to see you give me some details about yourself. I know you are living in Arizona. Um, and I wonder if part of the issue is the time difference. Um, is there a time difference? Can't remember this. Daylight savings time is a joke, but anyway, the the thing is, I need to have you on this so that we can actually speak to each other. I can answer your questions, and so what I want you to do um, is be aware that we need to be face to face in this class. I will be recording every lecture. That does not give you permission not to be here. As you know, we need to be able to talk to each other. The in-class exercise is a necessity as well because I need to know that you're getting the material. The in-class exercise will be related to the material of the week. It will generally be something you fill out and submit, but we'll work on that, and I will be here while you're doing it to answer questions. So let us look at this week's two discussions. First off, we're looking at drug calculation errors and the consequences that may arise. Drugs are useful. They're also dangerous. There is no such thing as a perfectly safe drug. We see certain things that we think of as being safe, like aspirin, like ibuprofen, and they're not. There is no such thing as a completely safe drug. The only completely safe drug is no drug at all. So errors can have consequences. If you underdose a patient, they will not respond to the drug. And if the patient is underdosed and is gone without being realized, then errors can come in from assuming that the drug isn't working when it really isn't being given in sufficient quantity. So the condition gets worse instead of better. Overdosing drugs, all drugs are toxins in one way or another at some dose. And overdosing can result in toxic reactions, and can some of those can be very, very severe, and even life-threatening, and if in the extreme case can be fatal. So one of the things that that you need to be aware of is that we have to be correct. There is only one correct answer in giving drugs, and that is the right dose, the right schedule, and the right route of administration. Those are three of the rights that patients have and that we have to observe when we are involved in dosing. There are some things here that you should be reading. Part of this class is done on your own, to be honest. I cannot possibly give you all of the information you need. You're going to have to do some studying. These two documents are really important for you to review and study. I will be giving you more at various times during the class as well. Where possible, I'll give you time during class when, rather than listen to me go on, I'll give you time in class to read through some of these materials and answer your questions. So we look at the different kinds of medication errors, and some of them are based on not understanding. The thing to do as a medical assistant is when there is something you do not understand, find out, look it up. We have an enormous amount of information available to us in medicine. Most of it is online. Some of it is not as readily available as others, but most of it's there. Don't hesitate to ask your colleagues. We do not function alone in medicine. If you have any questions at all, talk to your colleagues. So another one is based on the wrong route. This is not a great example. But I would say that if a drug is supposed to be given subcutaneously, and you remember what that means from your A&P classes, and it's given intramuscularly, it's not going to necessarily work very well. And in fact, could cause a major problem in the patient. So you should always check and make sure that you are doing things correctly. Do not assume that your primary, the person that is actually doing the prescribing, has properly written the prescription or the medication order. They're in a hurry, they make mistakes. So always check. The best MAs and nurses will go through and check everything and review it to make sure that first off, they understand it, and second off, that it's correct. And this actually has helped many patients avoid a missed dose. So there are based on just lapses in memory. So people forget there are something like 7,000 drugs out there in the formulary that we use, the broad formulary of medicine. It's, there's no way that everyone knows everything about that. Even pharmacists who spend their lives studying drugs, and that's all they do, who have, and they know more about drugs than physicians do, because that's their business. And physicians can't keep up with everything that comes out. But even they will go back and think, is that right? And check it. Because again, the only correct answer is the correct answer. You don't get any credit for doing everything right and then giving the wrong dose. So there are lots of other things to read. I suggest you look at these. Most of them are pretty quick and easy. They can be read in a hurry. They can be read actually in short time. And it's good for you to also, I suggest strongly that what you do is read some and let it digest. There's an old mantra in in a number of areas of learning and in medicine is we learn best in the rest. In other words, we read something and let it sink in. Or we practice something and let ourselves learn what we're doing. So I suggest that you do this in bites that you can take, but we still have to get through it. So the prompt is to actually, you can read the prompt yourself here. What you're going to be doing is looking at ways at what happens if there's a mistake in a dosage calculation. So take a look at this, answer the question. I've already made a post on this. Uh-oh, where did it go? I will get that on there immediately. Okay, so I've fixed that surprise that it didn't come through. Anyway, I've put in my initial post on this first discussion and the second discussion of the week. So you can read that, and since there's only you in the class, then we'll have to have you respond to my initial post, and then I will be responding to yours and probably asking you for some more information so that you can respond again. So let's set this up as a dialogue. Now, if we go back, if we look at the second discussion of the week, we're looking at units of measure. Units of measure are critical in making certain that we have proper dosing. We use three systems in medicine. We use the metric system, which is also known as the International System of Weights and Measures, or Système International, and is used worldwide, except for the United States and one other country, as the primary and in everyday life. It is also the official measurement system of the United States government, even though most people will use other systems as well. Let me see about who's online. Okay, so it is the most common system around the world, and in medicine we use it primarily in dosage calculations. Another system that's commonly used in medicine is the household system. We know this. It's what we use in our kitchens: teaspoons, tablespoons, ounces, cups, etc. We use this for giving dosing instructions to patients who are taking liquid medications. When we are talking to patients about this, we give them the information in measurement systems they can understand. So here is another example where in your practice as an MA, you need to assess whether the person you're talking to is capable of dealing with what form of medication. Many people coming into this country have been well educated in the measurement system of the metric measurement system. We had an incident many years ago where we were working with a Korean family that was here temporarily doing some graduate work. And my wife was in the store with the mother of the two children that were part of this family, and the mother, obviously, and looking at instructions for making a birthday cake. And so in Korea, they're strictly metric. So she pulls a box of cake mix off the shelf and starts to read the instructions. And she asked, what does 11/4C mean? Well, that's 1 1/4 cup. She had no idea what that was because she never used that kind of measurement before. And yet that's what we use usually here in this country. So you really have to know your patients as well. But the vast majority of the citizens here in this country still do not use the metric system in any significant way in their lives. So what we do for dosing is we have to calculate, because all drugs are denominated in the metric system. We have to calculate how much of a liquid drug, and we're talking oral liquids here. We have to talk. We need to look at how much of a liquid drug the patient is to take in orally, and then tell them how much that is in teaspoons or tablespoons. Now the conversion is 5 milliliters equals 1 teaspoon. And in fact, you can see this on some teaspoon measures you can buy here. They'll have 1 teaspoon / 5 milliliters on the handle. But for the most part, people don't think in terms of that. The little cups that we use for like children's Tylenol are delineated in both teaspoons and milliliters, which can cause some problems, but people are getting used to that. But we have to convert that. So if a person is to take 15 milliliters of a drug, of a liquid drug, at 5 milliliters per teaspoon, that's 3 teaspoons. 3 teaspoons is also a tablespoon. My preference is not to mix tablespoons and teaspoons, even though any cook will tell you that 3 teaspoons is a tablespoon. A lot of people really don't even know that, because they've never really looked at the system. So I always would prefer that you just use teaspoons. So anyway, that's the only real place that we use the household measurement system here. Household measurement also is in weights. Many drugs are given to the patient based on their weight. These are drugs that are injected. They're often very powerful drugs where we have to be very careful that standard doses are going to overdose some and underdose others. We have to sometimes convert weight from pounds to kilograms. Now, the issue is that, again, all drugs are developed in the metric system because all drugs these days are developed for international use. So when you see a dosing by weight, you'll see it as so many milligrams or even micrograms per kilogram of weight. Now, what that means is you need to know the weight of the patient. Most places that we see in a physician's office and even in hospitals weigh patients in pounds. So the thing you need to be aware of is that is that the weight is that there are 2.2 pounds per kilogram. So that means that we have to, if we're converting pounds to kilograms, we're actually dividing the number of pounds by 2.2. Use a calculator in all of these. Most weights are not going to be nice and easy to convert. So please use a calculator when you are converting pounds to kilograms. Okay. So we have to make, those are the two places that we see that we have to deal with the house, what we call the household system, or it has several other names, but it's household is a good enough one. There is one more system, which is an ancient system. The apothecary system goes back to ancient times. Has its roots in ancient Greek medicine, actually. Came into its own during the Middle Ages with the Pharmacy Guild, and it's not unusual for, at that time in the Middle Ages, for the guilds to have their own secret language, their own measurement systems. It was a way to control the membership and the work that was done by the members of the guild. So the apothecary system is based on is this ancient system that still survives in small measure today and is still used occasionally. It's based on something, the weight measure is based on something called a grain. And a grain is the weight of a grain of wheat. So you can see that this is not a precise measurement system. We have learned how to be very, very precise and exacting in our measurements over the years when we've been developing as a scientific society, and we've done away with such things. Part of the problem with the grain is that the grain can be converted to milligrams, but it depends on the product. It's really a bizarre system in some ways. For instance, if you look at a bottle of aspirin on the shelf, you may see a weight measure 325 milligrams, and it will also say 5 grains, because that's how it was originally done when aspirin was invented in the 1870s. And grains, in that case, if you look at that, 5 grains then is 65 milligrams per grain of aspirin. But if you go and look at some certain other drugs, the measurement is 60. So it's not a precise measurement. And in fact, most hospitals and many other medical facilities have banned the use of the apothecary system because of its inexactitude. Volume is based on something called the minim, which is 1 drop. And 1 drop, of course, depends on the size of the opening it's coming out of. We all know that. So we can convert that. And in fact, a standard conversion is that there are 20 drops to a milliliter, or 20 minim to a milliliter, except that there are other sources as well. There are other things that we've seen. Other common amounts are a dram, and in fact that survives today, and a fluid ounce. The drams today survives in the capacity of the bottles of medication. If you look at the bottles of medication that we sell, they are sold as dram capacities for volume. The and the dram itself, if you are at all into things like essential oils or many of those things, these little bitty bottles that are about maybe half an inch tall with a little screw top lid, those are 1 dram bottles. That'll give you an idea as to what the volume of a dram is. Again, old system, we don't use it. It will come up. You'll see some conversions in the exercise that we're doing in the assignment for the week. There is a couple of videos here that you can use, and we'll possibly go back through them later on in this lecture. When you are on, Amanda tells me that you're coming on or trying to get in. So here we are looking at the measurements and so forth that we use, and we have to accurately we have to find a way to reduce the risk of these things. So I've gotten some material in here from that I've developed for information about this system about the various measurement systems. It's critical that you understand units of measure. We will focus largely on the metric system in this class, but we will occasionally be converting things to household. And we will touch briefly on apothecary simply because you may run into it during your professional career. Okay, so that's that. So let's go back and look at the assignment for the week. I'm going to bring this up and use it as a talking point for what we are going to continue to look at for the rest of the day. So let me share that. You can bring it up on your own. Let's see. Right. So you should be able to see this. I have put a few corrections here. For one, what we want to look at is some of these abbreviations. So let's take a look at them. I'm also going to probably later on today upload into a page of resources each week some documents that will help you with understanding this material. Let's just take a look. They've gone for in alphabetical order. I'd like to talk briefly about some of the Latin abbreviations we use. A, capital A, or it can be a small a as well, will appear in many cases. A means before, just by itself. AC means before eating. Comes from a Latin phrase, anti-quibus, or anti-quibus, meaning before chewing. When we see an abbreviation such as AD, the A refers to ear. Think of that as the aural sense, A-U-R-A-L, the hearing sense. D stands for right. That means, that comes from the Latin word dexter, which means good. The Latin word for left is sinister. We have it right here. Sinister, that's the Latin word for bad. That comes out of the fact that the bad guys would use their swords in the left hand, as opposed to the Roman centurion who was always trained to be right-handed. The bad guys would use their sword in the left hand, which meant they could reach around the shield more easily. And so they were the bad guys. A little Roman history here and prejudice, obviously, especially considering the number of lefties that are in the world. But in case of when we want both, we use the term you. This applies to the eyes and the ears, and we use it that way. BID you've seen twice daily. Cap is capsule. D/C or DC means to discontinue. We see this in medical records, discontinue. They'll discontinue the use of a drug and they'll have it in there. D5W, often the 5 is a subscript, means 5% dextrose in water. D5NS is 5% dextrose in normal saline. Sodium chloride is a misleading term in this case. Normal saline is a very specific material. It's 0.9% sodium chloride solution in water. We dextrose, D5W, D5NS, and normal saline are very, very common IV fluids that are given to patients when they go into a hospital. We have some abbreviations related to drugs. EC means enteric coated. What that is a layer on the outside of usually a tablet that will prevent it from being broken up in the stomach. It will actually get through the stomach and get into the upper part of the small bowel before it starts releasing drug. This is common with drugs that are irritants to the stomach. Aspirin is something that we see this a lot. Aspirin is very irritating to the stomach. Ibuprofen, we can see enteric-coated ibuprofen. Ibuprofen is even more irritating than aspirin. ER, extended release, could also be emergency room. This is one of the issues. We'll get back to the use of abbreviations in a bit. Gram is G, and it always follows a number of grams. That number can be a decimal. It can be a whole number. Grain, again, in this case, we have people who make mistakes and they'll abbreviate gram GR. This is a very, very risky error to run into. When you are using drugs, we are very careful to abbreviate gram as G. GR means grain, which we discussed above, that the apothecary measurement. And it always precedes the number. So if we were looking at that and looking at an aspirin tablet, it should not say 5 grains. It should say GR5 on the label. And the number of grams, always the number precedes the symbol. So that's another way of knowing which one is being used. GTT is drop. It comes from the Latin word for drop, which is gutta, G-U-T-T-A. Our HS, bedtime or hour of sleep. One of the few abbreviations we use that in terms of our dosing, that is not from a Latin root. IM and IV are injection types. You know this from, I think, from some of your other classes, intramuscular injection, intravenous injection. We have to be very careful about the route of injection. Some drugs are to be given intravenously, some intramuscularly, some subcutaneously. We have to be very careful about what route of administration and the actual location of that administration. Kilogram, long-acting, capital L for liter, always a capital L. Why? we can go right down here to something that I think is not supposed to be here. M capital L for milliliter. A milli is 1,000th. So it's 1,000th of a liter. ML can be mistaken for M1, maybe. Nobody uses it. We should not use M small l at all in medicine. So we have others here. Here is NS, which is normal saline. We have the abbreviations for I. Think of I, the O, as being ophthalmic. That's another word for the eye, related to the eye. So we've got right eye, left eye, or both eyes. Ounces, you won't be using. P means after, comes from the Latin word post, after. And PC is after meals. This is a dosing route that we use. Some drugs need to be given before eating. Usually they'll usually specify a time if it's an issue with absorption of the drug. And some drugs can be taken with food, no problem. So we don't have any instruction about that. It's a logical question, however, from a patient. Can I take this with food or do I have to take it without? After meals often will have a time associated with it. So keep that in mind. PRN as needed. This is something that you see, especially with narcotic prescriptions. As needed means if you are experiencing the symptoms that require it. Okay. Q and then a number followed by an H means every. Q means every. In this case, X number of hours, 2 hours, 4 hours. It could be a scale of 4 to 6. We often see this again with narcotics, 4 to 6 hours. QID means 4 times in a day. QID and Q6H are very similar. Q6H is much more precise in terms of the timing. Drugs act by maintaining a consistent plasma concentration. And that is calculated, and we look at that when we develop drugs. That's how we determine the amount of a drug. So, and the rate and the speed and the frequency with which we give it. PR is per rectum or rectally. SL means under the tongue, sublingual. ER and SR mean much the same thing in terms of this sustained release. In other words, the drug is released over time instead of just decomposing and you get the entire dose at once. Stat means now. Stat has several interpretations. In an emergency room, stat means I want it this instant. And in an inpatient situation, stat means give it now rather than waiting until the next scheduled medical med pass time, the next scheduled time of medication administration. Sup does not mean supplement, it means suppository. The abbreviation we use for tablespoon and teaspoon, we really don't even like to use these abbreviations. We want to write them out. We don't use the cookbook abbreviations of capital T for tablespoon and small t for teaspoon. since especially when we're writing things out, it can be very confusing. And being confused, it can either overdose or underdose. So, and in reality, pharmacists are trained and pharmacy techs are trained to write out tablespoonful or teaspoonful as a word, full word, for this. So be very careful of these. TID, and that can be small or large letters, doesn't matter. 3 times a day. PV is per vagina. So those are major abbreviations. There are pages and pages. So we also use some other abbreviations in here. So if we look at this, we can, you'll be interpreting this. So, go back up and read the instructions. I'm not going to give you the answers here, but let's just look at the abbreviations we use in calculating doses. The dose ordered, or D, is what the prescriber has given instructions for the patient to receive. This could be milligrams or micrograms or whatever, and this will or grams even. And so this is what the patient is to receive. The DH or H, the dose on hand, is what you have in stock. So if you have a dose of 5 milligrams, and it's common, might be a drug like Coumadin or warfarin. If you have a dose of 5 milligrams, but what you have in stock is 2.5 milligram tablets, you're going to be giving 2 of those tablets. So the dose ordered is what the physician or prescriber has said. The dose on hand, or H, in the way I do most of my calculations, is what you have on the shelf. They don't necessarily match up. Many times they do. Coumadin comes in very many different potencies, so you might actually have 5 milligrams, but you use this when we calculate the number of capsules or tablets we want the patient to take. So if we look at here, we have some interesting takes on how to think about the measurement systems. Household is based on things that you'd have in your house, and we all have teaspoons and tablespoons and cups and ounces and other things that we have in the home. Metric, this is basically universally used in medicine, and you'll be using it all the time. Apothecary, we will not spend a lot of time on. The other systems here, we will look at, we won't dealing with the avoirdupois system. Liquids are always measured in volume. Liquids can be, they can be solutions, suspensions. A solution is a clear mix of solvent, usually water, and drug. No solids in it. Suspension is something that contains solids. One of the things about suspensions, and you have to warn your patients, is that you always have to shake the container before dispensing a dose. Syrups are big, sweet, often thick liquid forms. Elixirs are often alcoholic. And so our units, liquid units, can be milliliters, teaspoons, tablespoons, drops. If we're putting doses into eyes or ears, it's often drops. So you'll see the GTT measure. Solid units can be powders. Note that we've got liquid units, we've got lotions. Here we have creams and ointments. These are often not given in liquid measures and not given in grams, because you're told to put a piece, like a cream or an ointment, you might be told to put a pea-sized amount onto whatever it is you're putting on. Creams, ointments, and lotions are all topically administered rather than consumed or injected. Units of measure. Let's go back here and take a look at these. We talked about grams, milligrams, kilograms, micrograms, okay? Kilograms are weight measures for patients. We don't dose in kilograms. Kilogram is 2.2 pounds. Think about that. A gram is 1/1000th of a kilogram. A milligram is 1/1000th of a gram. And a microgram is 1/1000th of a milligram. So it is actually 1/1,000,000th of a gram. We use micrograms for dosing very, very potent drugs. Okay. Again, I will emphasize we never use m(l) as an abbreviation for milliliter. It's always M(L). Same with liter. They do this correctly here. We never use a small l for liter in medicine. And the same warning about teaspoons and tablespoons. Write out either TSP or TBSP, preferably write out the whole word. Fluid ounce and ounces, pints, quarts, grains, and pounds you probably won't ever see. A milliequivalent. This is a measure of potency that's based on chemistry. Milliequivalent is a dose. You'll see this with drugs like potassium chloride or sodium bicarbonate, which are given to patients in various means. You'll see this written down. The prescriber will use this, and it'll be treated the same as any other measurement system. There's one that's not here. It's called the unit, and this is a measure of biological activity, and it's used for certain antibiotics and other biologically derived products. Okay, so if we look at here, if we're looking at the comparison of measurements, a teaspoon is 5 milliliters. Since 3 teaspoons is a tablespoon, then a tablespoon is 15 milliliters. And what we're doing is looking at the comparison. We'll have a few of the apothecaries thrown in. So we can look at this, and when you are looking at this, if we look at this, an ounce is 30 milliliters. An ounce is also 2 tablespoons. So an ounce is 30 milliliters. We use our cup measures, 8 ounces, it's 240 milliliters. This 5 milliliter number is not exact. It's really 4.8 and a bit. So these are estimates, but they are within the acceptable margin of error in terms of drug dosing. So if you go to online for conversions and you ask for a conversion of teaspoons to milliliters, you're going to get a different number than 5. But 5 is a good and safe approximation. So if you do that as well, you're going to get, instead of 960 milliliters per quart, you'll get 946 if you go online and say how many milliliters to a quart. We generally suggest you start understanding that these approximations are acceptable. So a kilo is 2.2 pounds. As I said before, 60 or 65 milligrams per grain. 30 grams in general is an ounce. It's not quite, but close enough. So our metric equivalents, these are important. That you really understand them. So we've got 1,000 milligrams per gram. A tenth of a gram then is 100 milligrams. A thousandth of a gram is 1 milligram. So we can go that way. Generally speaking, we go directly from grams to milligrams. We don't use the intermediate. The international system, the metric system, uses a step for every power of 10. So there is a 0.01 grams, which is 10 milligrams, and there is an abbreviation for that. We do not use those in medicine in terms of calculating doses of drugs. We use grams, milligrams, and then, as I said before, the microgram, which is 1/1000th of a milligram. So it says right here, 1,000 milligrams. So we've got some equivalents here. A liter is 1,000 milliliters. Milliliters is what we use. We use liters when we're talking about large volume injectable drugs known as large volume parenterals. These are bags that will come in 250 milliliter and up sizes. It's not uncommon. Most of the IV fluids that you see hanging from the IV rack for patients in a hospital are going to be 1 liter bags. So the 100 ml bag is what we call a small volume parenteral. So those are pretty common. 1 milliliter is 1/1000th of a liter. The nice thing about the metric system is that the conversions are very common. We also have a volume. 1 gram of water occupies a volume of 1 milliliter. So this system ties together very, very well. Now, 1 milliliter is also equivalent to a cubic centimeter. A centimeter is about 4/10 of an inch. If you look here, about this much. If you take a cube, let's put that where you can actually see it. If you take a cube, 1 centimeter on a side, that's a cubic centimeter, or cc, that is 1 milliliter. It is also of water, at least 1 gram. So we have a few concepts here. Ratios. A ratio can be expressed as a fraction or a decimal. It's just a relationship between 2 numbers, 2 measurements. So the example here, 1 is, and it's read as 1:3. All you're doing is comparing. So we can also state that as 1/3, 1 divided by 3. Obviously, this is a mistake. Okay, so we want to change that. So this obviously was a mistake. Okay. So we can convert that to a decimal by simply something you just divide the numerator, the number on top, by the denominator, and we have an answer. So we can do that. There's several examples. Proportions are an equality of ratios. So let's see if this link actually works. And let's see if we can actually share this. Oh, good. Is it going to work? Yes. Okay. So this is very short.
To determine if two ratios are equal to each other. We can check to see if they are equal by using division. In our example, 1/2 or 1/2 or 1:2 is equal to 6/12. We'll check each side of the equal sign. First, we'll check 1/2, in which we'll just divide 1 by 2. This gives me 0.5. I'll do the same thing with the other ratio on the other side of the equal sign. 6 divided by 12. And that gives me 0.5 as well. That means that 1/2 or 1/2 is 0.5, which is equal to 6/12. We can determine that these two ratios are equivalent.
Okay. All right. Okay, so that was pretty simple, and that is one way to check them. Note that she wrote 0.5. In medicine, if we have a number that is less than 1 being expressed as a decimal, we put a 0 to the left of the decimal point. This tells whoever's looking at the number that whether or not they can see it, there's supposed to be a decimal point between the 0 and the next digit. Now, if there is a number like 10.5, then that's different. We don't put a 0 in front of the 1 that's part of the 10. We do not also, if we have a number like 25, we do not put 25.0. If that decimal point does not come through, then we have a number that is 250, or if it's not legible. So when we are dealing, especially with drugs and doses, we use 0 point and then to express a decimal that is less than 1. Okay. All right, so you can check all these things. Let's take a quick look at this. All right, let's take a look at an example of calculating a dose. We use this dosing formula here. I actually, this is actually, the dosing formula should have an equal sign here, and it's going to equal the number of capsules that are going to be given to the patient. And so what we're calculating here is exactly that. So if we look at this, this is a good example, 500 milligrams of cephalexin by mouth. So they could have put that as PO. Stat, that means right now. Your office has this dosing form, 250 milligram capsules. This answer is pretty obvious. You're going to give them 2 capsules. Simple as that. Our example here should show this. As if we put 500 into this position on the formula and 250 into this, and then Q is capsule. Q also is sometimes abbreviated V, as with the word vehicle thrown into it, but Q is a quantity as well. So you'll see both sets of abbreviations, Q or V. Anyway, if we do that, we have 500 over 250 times 1 capsule, because Q is what we have. The dose on hand is the amount of drug in 1 capsule in this case, or tablet, or whatever. So if we do that, 500 over 200 times 1 capsule, milligrams cancel out, we get 2 capsules as the answer. Here we have an example of a drug that's going to be given to the patient for or Narcan to try and rescue them from an overdose of opiate. So the physician orders 50 milligrams by mouth right now, and what you have is 100 milligrams per milliliter. Okay. So what we have is, in this case, the quantity is 1 milliliter. Why do I know it's 1 milliliter? Because there is no coefficient, no number in front of ml. So it tells me, and so that implies that this 100 milligrams is in 1 milliliter. So we have the dose being ordered is 50 milligrams, on hand 100 milligrams, and the Q, the quantity, is in 1 milliliter. So again, we do that, and we're going to give a half a milliliter. Now, this is by mouth, and we're in the office, so we're not telling a patient to take X number of teaspoonfuls. We are giving it to them ourselves, and we can do this by several methods. We can measure out 1 milliliter or half a milliliter in an oral syringe, or we can measure it in some other device that's available to us. So that's what we're going to be giving. So we're going to, so now you're going to have several problems here. So when you analyze a question like this one in number 26, we're going to be looking at the order, the amount. The name of the drug is not important to solving the problem. Okay. The condition, in this case diabetic neuropathy, is also not important to the problem. So what we do is we're looking at the order. 200 milligrams is the order. Capsules is, in this case, Q or V in the way I solve them. And then the dose on hand, H or DH, is 100 milligrams. So you look at the problem, figure out what you need to know. Is the name of the drug important? Yeah, you need to get the right drug for sure, but it's not important to the math. Okay. Okay, this one is going to be converting to tablespoons or teaspoons. Okay, so that's what you'll be doing in the assignment. Let's go back to the module. Okay. So that's what you'll be working on. I'm going to pause the recording and try to email you. And at what was at that time Williams Air Force Base, which is now Chandler Airport.
Oh, really?
Yeah, and then we moved to Luke, which is over by Glendale.
Oh, nice. I was born in Mesa. That's kind of like right.
Yeah, right between.
Yeah.
Yeah, nice area. It's grown a lot since I was there. I left there in 1964, so it's quite.
Oh, really?
Quite different.
Yeah.
Than when I lived there. But yeah, I remember Paige. We used to go up to the mountains a lot when I was there as a Boy Scout. So
yeah.
So we'd go up, and it's a nice area.
Yeah, I love it.
Mountains to be cooler than the valley.
Yeah, way cooler. That I don't know how I ever even lived there. Like it's like way too hot, to do anything.
Yeah.
But Paige seems to be pretty perfect for me. So
excellent. Well, I'm glad that that's the case. So let's go quickly. There's a couple of things about that I'd like to say. Remind you about the discussions. You really need to read the material and look at some of the links they have. There's a lot of information there that you'll need.
Okay.
And the assessment, I've actually set the assessment up for multiple tries because I view assessments as learning tools.
Cool.
So you have multiple tries. You can do at least 3 attempts to learn and maximize your grade. Now, the way it's set up, the attempts may not be identical.
Okay.
Because
what does that mean?
It draws questions from a question bank randomly with each try.
Oh, okay.
So, but you can see what's in it and go back and review materials. So there's also no time limit on it.
Cool. And with the discussion, so like usually they're due by like Wednesday night. Is both of the discussion like the actual discussion part? Are they both due by Wednesday or what?
They will be, considering that we didn't have class on Monday. I am not going to be hard-nosed about it being done by tonight. You may want to try and just get them done to get them out of the way.
Yeah.
But I'm not going to worry about that at all.
Okay.
I would rather you give it some thought. But one thing is, since you're the only student in the class, so it's just the 2 of us.
Oh, really?
Yeah.
Oh my goodness. I thought that's so funny because I was texting my friend. We thought that we all had the same class. So I was telling them, I'm like, will you let them know that I'm not going to be there for a second? Like I have to go do something. And they were like, yeah. So that's why I was like confused when I showed up and it was just me. So I'm sorry about that.
Oh, yeah. Yeah, it's just the 2 of us in this class.
Okay.
So what I want you to do is I've already made a post into the discussions. And what I'd like you to do is respond to my toast. And
Okay.
and also, put in whatever you want to put in for your primary post, and then we can sort of make that as a dialogue.
Okay.
Give you a chance to to actually think about these things. Okay, so it's a little hard for you to respond to other students when there aren't any.
Yeah.
So we'll do it that way. All right.
Okay.
All right. So yeah, and I'm not, as I said, I'm not going to be terribly worried about getting the primary in this week for sure, the initial post. And we will spend part of Monday's class each week looking at the discussions and making sure that they're clear. Okay.
So our classes are on Monday and Wednesday? I haven't even looked at it.
Yes, Monday and Wednesday.
Okay.
You know, we'll start off with a quick review, take questions, then go into whatever lecture material I have, and give time for you to actually do some of the work that needs to be done each day, because it's a busy class.
Okay.
Uh, and I know you've been in it before, so I know you can. I know you have your own way of solving some of these problems, and that's okay. I have no problem with that. Actually, you might teach me another way of doing it, so that would be good.
I've already taken, like, this is the one that I didn't do good in at the beginning. Is that
Right? Yeah, it was
okay?
last January.
Okay.
Um, and yeah, you missed a bunch of classes. I know you had a lot of issues.
Yeah,
So I expect, you know, and I expect you'll do fine in this one, this version.
I think so too. I'm a little bit more focused now, so I mean
Yeah,
a lot more. So
yeah, you seem quite relaxed, so that's real good. So,
yeah.
okay, so let's take a look at the in-class exercise, which I'd like you to go ahead and work on. Normally speaking, I will prepare a short exercise. I mean, it's hard to have an in-class activity with just you and me. So it's basically going to be a little sort of mini quiz
Okay.
and something to help you um, consolidate some of the information from the class. And you've seen most of this before.
Okay.
So what this will be, it's most of the time it's going to be to download a worksheet, um, fill it out, and then submit it to me.
Okay.
Submit it to the box. So you're submitting a Word. This is a Word document, so you can just put your answers on it and submit it.
Okay.
Okay. So since we have only about an hour and a quarter left, I want you to go ahead and work on that.
Okay.
All right. And I will probably mute my microphone. And if you need anything, just speak up and I'll unmute. Okay.
Okay.
Great.
Cool. Oh, I'm gonna stop my video so you can't see my face when I'm thinking. Okay. Okay.
Okay, Kayla, I'm just checking in. How are you doing?
I'm doing good.
Excellent.
I haven't done math in a while, so it's gonna. I'm not very good at math, as you know, but I don't know. I'm trying. It's easy. Like this stuff is easy. It's just making me think. Like, here we go again. You know.
And actually, you'll do just fine. You can do this. It's not a, you know, I know you can drive, so
But yeah,
that's math. So
yeah, but yeah, I like it. I like how it's set up. Like the questions are easy to just read. Like some of the classes are kind of more like difficult with how they word things. If that makes sense.
yeah, and I really don't understand why people do that.
Yeah. Me neither.
But you know, because it ought to be a straightforward question because most questions are straightforward.
Yeah. Um. I'm gonna ask me questions. Like, do you like for me to like just look it up on the internet, or do you have like a specific like resource that I should use, or like?
You'll find actually that the most of what you need is actually in the worksheet for the assignment.
Oh, okay.
This is all based on the topics that we're covering this week, which is there. They're just different questions. So you
Okay.
can find a lot of it there. I'm also going to be uploading some material into the shell that can give you some more resources.
Okay. Thank you.
You're welcome.
But yeah, I'm doing okay.
Good. Well, I'll let you get back to work then.
Okay. I'm just using the restroom real quick, so if you say anything, that's why.
Okay. Are you getting close to done?
I am.
Okay.
I just suck at ratios, I'm not gonna lie.
So how are you doing with those?
I don't know. Like, what is the easiest way to do it, do you think? Like, how do you?
You mean type in the answers or?
Like, converting them? I don't know. It just, those
Okay.
simple things confuse me, I don't know.
Yeah, a ratio is simply another way of writing a fraction. It's a comparison of two numbers. So the 1:3, for instance, would be read as 1:3. And it can be expressed as the fraction 1/3 or 1/3.
Okay.
That makes sense?
Yeah, it does. I just,
Okay. And
so
then you
what,
know how to convert fractions to decimals.
you say, how do I do that?
Yeah, you know how to do that, right?
Yeah.
Yeah, you divide the numerator, the top number, by the denominator.
Yeah.
Okay. And
So,
yeah, go ahead.
sorry. If I were to do, I just want to make sure I'm doing this right because I don't want to think I'm doing it right and then I'm not. But the first one, it says it's like converting the ratio to the fraction.
Yeah,
So 6/15 would literally just be 6/15,
yes,
and then 1/6 would literally be 1/6.
yep.
Oh my goodness. Okay.
Simpler than you thought, right?
Yeah, I think, I don't know. This is why I suck at math. I'm like,
Well, no, but actually, what I find is that most people think that it's harder than it really is.
yeah, exactly. But then when you think it's too easy, then you feel like you're like doing something wrong, you know?
Right. Yeah. And don't get caught up in thinking something is too easy because quite frankly, most of the time it's pretty straightforward.
All right. And then converting the ration or the rations to
Ratio.
decimals, rations. Okay. Um, if it's 3/8, what would that be?
Well, first convert it to a fraction
Okay. So,
and then convert the fraction to the decimal by doing the division.
okay. All right. Yeah, I don't know if I'm gonna have this done by the time we're done, but I will definitely have it done.
Okay, make sure you just get it submitted.
Okay.
So let's just then, since you're not quite done, let's just talk about a couple of things.
Okay.
For one, make sure you're doing your daily checkpoints.
Okay.
Okay. So the rest of the week for you will be to work on the discussions, the assignment, and then when you've done all that, look at the assessment.
Right now.
I have added to the week one materials a page called Resources from Instructor. And it is a set of 5 documents that I've uploaded.
Okay.
One of them is the assignment sheet with my corrections on it. And the rest of them are things you can use or read to help with the discussions and with the rest of the assignments.
All right, and this is in the assessment part
Yes,
where you uploaded these?
I uploaded them, yeah. If you may not see it yet unless you've refreshed your screen.
Okay. Let me see. Hmm. So it would literally be like in the assessment, like in that page where you would go to take the quiz.
Well, the resources that I've done is a separate page.
Oh, okay. And that's just like in modules, like,
That's in the week 1 module.
okay.
I just added it while you were working on this in-class activity.
Oh, cool. Thank you so much.
Oh, you're welcome.
Oh, I see it. Resources from instructor.
Right.
Okay. All right.
Okay.
Yep.
Well, do you have any other questions?
I do not.
Okay.
If I do I just email you or what do
Just
you
email
prefer?
me. I check my email fairly regularly.
Okay.
I'll get back to you as quickly as I can.
Okay.
All right.
All right. Thank you
So
so much.
go ahead. Oh, you're welcome. You're welcome. I'm glad to have you back in class. We're going to get you through this one.
Me too. Yeah, I'm sorry you have to deal with Michaela through math.
Don't worry about it. Don't worry about it. I enjoy teaching math, so that's not a problem.
Okay.
Um, so I will see you Monday morning
Okay.
at 9, and we will get started on the second week. You may want to just quickly look at it, over the weekend and see where we're going to go, because we're going to actually start moving into dosage calculation this week.
Okay.
Okay?
Okay. Thank you again.
You're welcome, Kayla, and have a good weekend.
You too.
Thanks. Bye now.
Bye.